So my name is Brian Rubin. I'm head of solution engineering at SymphonyAI Industrial, and I will walk you through some informative stuff about our OSI Pi connectors. Actually, it's Aviva Pi nowadays, which they have been bought, so now it's Aviva Pi. So I will walk you through how we actually integrate or ingest data from an OSI Pi historian into our flagship IRIS Foundry platform. So the agenda for today's webinar is I'm going to give a quick overview of Symphony AI Industrial, who we are, what do we do. You probably already know that, but it would be good to have a refresher. Then we will jump over some AI power insights with knowledge graphs, how we can using AI, we can drive some insights from knowledge graph. Then we will cover some challenges that we faced, and I'm sure a lot of our customers would face, challenges unifying the historian data with other OT and IT sources to be able to get a complete picture of your asset and process operation. We will give a quick demo, maybe 10 minutes, 10, 15 minutes demo of how this actually works, how we would integrate the Pi data into our knowledge graph. And then we will quickly wrap up and leave some time for question and answers, as Tyler said. With me today, we have Jam Jose, who is the head of applications at SymphonyAI Industrial as well. He will do some of the presentation. So first, who are we? Who's SymphonyAI? So SymphonyAI is a multi-vertical company that specializes in AI for these different verticals. We have an industrial, which is the division that John Tyler and myself are from. We have a retail CPG vertical. We have financial services, media, and enterprise IT. Some of our customers are Cargill, Seagate, NRG, Siemens, a lot of very big names, and also a lot of smaller names depending on the capacity. We are very proud of our partnerships. We are striving to have as many partners as we can to get our platform out there to simplify everyone's life. So some of our partners, we have been named the Partner of the Year of Microsoft for the Industrial Division this past year in 2024. Some of our partners are Infosys, EY, Slalom, Dell Computers, L&T Technologies, HCL, TCS, Mesa, Wipro. These are just to name a few. We have a few others. And then we've also won several awards, which you can see here. I'm not going to toot our own horn, but we're doing quite well this past year. Again, I would like to highlight that the biggest award, or not biggest, one of the awards that we received that we're very proud of is our Microsoft Partner of the Year Innovation Award, because with AI, the way that AI is moving nowadays, it's moving so fast, so many new things are coming in. So being called out by Microsoft as one of the as the innovative AI company in the industrial sphere, that's very important to us, and we're very proud of that accomplishment. So maybe we'll show you a bit what won us this award. So our flagship platform is what we call the IRIS platform, Industrial Reasoning Insights System, that is able to connect your asset, the assets of your plant, and all the other data that you have, OEE data and ERP data, all your data into a single Delta Lake platform, a data platform where you can run models simply and efficiently. You can deploy models on that data, gain real-time insights, gain historical insights, comparisons between different processes, different assets, predictive maintenance, forecasting of asset performance and stuff like that, we do have several applications that come hand in hand with our flagship IRIS Foundry, such as collaborative workspace. We have predictive assets, so APM and KPI. We have and also we have a connected frontline worker, which is very important because if we want to do a maintenance work on our asset that we're collecting data on, we're finding, using our analytics, we're finding some anomalies, we're finding some issues, or finding, let's say the process is not performing as we would expect. In the end, someone needs to go and actually service that issue. They need to go and maintain the asset. They need to go and check what's going on, do a five-point check. They need to do a five-point walk around the asset to see around the plant to see what's going on, what are the connections, why is the data not giving us the right information. So with the connected frontline worker, we understand that a lot of operators, they're not sitting in front of their computer all day long, but they need to be able to know what are the steps to complete the operation, the procedure to service that asset, and they need to have access to that data in the palm of their hands, either on a tablet or on even on a mobile phone, to be able to see what's going on with this asset, what's the full information, and how are we going to service properly this asset and resolve any alerts that we got and process optimization that we got. So that's a very high level, and in the moment we will show you also how it will sort of end to end with our IRIS Foundry and getting all these connectors. But the key to be able to gain these insights, to gain these analysis outputs for our operators to know what procedures they actually need to perform on the asset in question, or to know which assets even to inspect, we need the data. Without data, data is king. Without data, you can't do anything. And the more data that you have, for more systems that you have, the better you'll be able to analyze the system. So that's why we set up this webinar, to show you how we can connect to different connectors. Here we will focus mainly on the PI connector, because that's a very commonly used historian for industrial data. And to explain a bit more about the complications and how we actually harmonize this PI data with OT, IT data, and how we accomplish the connector, I will pass it on to John.
Thank you, Brian. So here we are in 2024. The term that was coined, Industry 4.0 or Manufacturing 4.0, as you all know, that began in 2011 by the German government. And it started with something called cyber physical systems. And the idea was to get the computational systems along with the physical systems, get them together, interconnect them, and gain value out of it. But here's the problem. And the problem lies with accessing the data in those systems. And here we have, on the slide, we have some survey data from the Manufacturing Leadership Council. The first problem is always data accessibility. How do you access the data lying in the various levels, L2, L3, and L4? When you access the data, post accessing the data, how do you look at transforming the data so that it can be consumed by downstream applications? So that's the first challenge that enterprises face in this Industry 4.0 journey. And the second problem is once you tackle the accessibility and the transformation, you come to the point where you need to contextualize the data. And what we mean by that is you look at data from multiple sources, IT data, or coming from ERP systems, CMMS systems, OT data coming from your PLCs, and how do you enrich the data? How do you find how do you find certain insights in the data and contextualize data coming from multiple sources? For example, if you are tracking a furnace and monitoring a furnace, how does the work order data, maintenance work order data of the furnace over the past 3 years tie in to providing a predictive maintenance model or building a predictive maintenance model from the live data that is coming in from the furnace via time series format? So that's a data contextualization part. So that's the second challenge. The third challenge is After you get the first two right, the accessibility and the contextualization, how do you go about building insights? You have various dashboarding tools, you have various tools and technologies available now in the market, but how do you scale them? Can you have a very succinct view of what your asset hierarchy is, what your asset map is of across your enterprise, and that's where the scalability of insights come in. And so these are the three challenges that we are addressing with industry with IRIS Foundry and the associated applications that runs on top of IRIS Foundry. Next slide, please. Thank you. So this is a schematic of how IRIS Foundry accepts data and transforms the data. So from left to right, you have the enterprise systems at L2, L3, L4 of the ISC 95 architecture. Those could be historians, those could be your MES systems, it could be your ERP, CMMS systems. We have a set of connectors, we have a suite of connectors, data connectors. We can extract from this, and regardless of whether the system, whether the data lies in your OT, which is level 3 and below, or in IT, which is level 4 and above, or in your cloud, we have ways and means to deploy IRIS Foundry and its suite of connectors to where to close to the data by being mindful of your security and your access privileges that your enterprise, without infringing on your enterprise security policy. We are able to extract the data and then we send it to what we call a data landing zone. And from there, we run specific data transformation pipelines for the numerous data streams from various assets and various data sources. And all of that is then contextualized and put into IRIS Foundry, which is then consumed by the downstream applications. And that is the block on the right side. You have plant insights from bottom, predictive asset intelligence, copilots, connected worker, connected field worker, and so on and so forth. You could also take this data, the insights, or rather, post the data modeling, the insights, and send it to your own in-house data modeling, data business BI tools like Power BI, or send it to your storage on OneLake, or any other existing applications can consume it. So that's what the IRIS Foundry provides you to ingest, transform, contextualize, and apply your data from IT and OT. Next slide, please. So in the previous slide, we saw a list of a schematic that showcased the list of connectors. In this particular slide, we are going to look at the OSI PI historian. And the PI historian comes with two specific servers. One is the asset framework and the other is the data archives. Like you create your asset hierarchy, your enterprise asset hierarchy within the asset framework. And then you can then tag that, you can map that onto IRIS, point to specific assets and the tags, define an extraction frequency, and extract that data, which lands in the data landing zone. And you can have numerous landing zones, as Brian will demonstrate in the next step. And then it is consumed by IRIS Foundry and its associated downstream applications. Brian, over to you.
Thank you very much, John. So I will now start sharing my other screen. Hopefully I'm not going to be looking too much to the side because I am looking at another screen. So what you see here on the screen is our knowledge graph. So the knowledge graph is used to get a very clear overview, very simple overview. Actually, it's not very simple. It's simple to view, but it has so much information in it, as John specified before or mentioned before. The key challenge when you're looking at analytics is that there's so much data out there, even from the data that you get. And when you run analytics, there's so much insights, so many insights that you get, that if you only had an asset hierarchy, it would be or just the assets themselves, even contextualized as they may be, it's very hard to tell where are the dependencies between the different assets in your overall performance. So, for example, today, I was tasked with inspecting our absorption and stripping module or area within our Orion Petrochem plant. So I work for BLR Corp. In our BLR Corp, I have two plants, Whitefield Refinery and an Orion petrochem plant. And in my Orion petrochem plant, I have an air compression, absorption stripping, feed, CW system, and a shift reactor area. So let me go and focus on my absorption stripping. So I see my absorption stripping is performing at 84% health. I can zoom in to the different assets that I have and see and inspect what is going on here. But if I go back to my main area, my absorption stripping, I can zoom in as well, into my absorption stripping, I see that I have a few alerts. I see that the absorber has a critical alert, while the stripper has a moderate alert. So me as an operator, as I'm inspecting this and I'm trying to see, okay, I'm at 84%, my goal is to get the health score up to 90% of the absorption stripping. I would want to inspect the main critical alerts, the main issues that I have in my area, which for me, it's the absorber at the moment. So let me go to the alerts. So this is a very easy access point to my alerts. And I see, yep, I have a few alerts here. And I see that the most recent alert on the 28th of March, I see that the absorber has some issues. Let's see, let's inspect. So the absorber has some CO2 excursions and some foaming. Okay. The recommendation is to increase the amine circulation flow and check. Okay. Let's see. Oh, it's been happening quite a bit over the last few days. So this must be something problematic. I can see, okay, there's a CO2 slip, but what would cause a CO2 slip in my absorber? Let's go back to I did mention the stripper. So maybe I should go to the stripper, see what's going on here. So I see, okay, there's a few similar assets here. Let's see, I can compare them. My stripper is performing at 83%, whereas the reflux drum is at 89%. Okay, let's see. So I want to check the, yeah, let's leave, see what's the difference between these two. Okay, I see some issues here around the stripper. Let's go see. So let's go back to my stripper and see the actual alerts for the stripper. Okay. Oh, a foaming alert. That explains why we have that CO2 issue on the absorber. It looks like, okay, I need to go get some antifungal chemical, and I'm going to assign this to Kieran to take a look at what's going on and execute the procedure. Okay, good. So me as a manager inspecting this, perfect. That was quite easy. Very easy to get the correlation between the different systems that I have, see what's the cause, and assign it to the appropriate person. Well, tomorrow I need to inspect the reactors. So let's see my shift reactors. So right now I have an HT, a level 1 shift reactor, and a level 2 shift reactor. Wait a second, something here is missing. Let me go to my system. So in my system, this is my Pi. This is my Pi system. I see in my shift reactors, I have an HT shift converter, which I have, an LT shift converter, and a heat exchanger. Okay, so I'm missing the heat exchanger from my knowledge graph. Okay, and let me see. So here has a few attributes that I can look. I have, okay, liquid level. Okay. So now so that means that I need to bring my heat exchanger into my knowledge graph, which right now only has 2 assets. I need a full picture of my operation, of my asset hierarchy. So I need to go and bring this heat exchanger, which exists within my OSI Pi. How would I do it? And how would I make sure that it remains in this hierarchy? I don't want to now create a new connection to the OPC UA, for example, because I have it in OSI Pi. I don't want to create even an MQTT bridge, or pass it in with any of these connectors that we have. So maybe I should use our OSI Pi connector suite. So our OSI Pi connector suite allows me to specify the Pi server, the database, and the authentication credentials that I need to access that Pi database. Now, this, as John explained, is living on the OT or wherever you have the Pi historian deployed. So this component, this connector component, is going to connect to a landing zone and push the data to the landing zone, and then the landing zone will push the data directly to our IRIS Foundry. That way, we don't need to whitelist the Foundry on each and every system that you have. So I have it. I have my OSI Pi. I have a Pi demo 01. This is my database. Then I can configure my landing zone. So here I specify the tenant ID, specify the tenant of my IRIS Foundry that the landing zone will need to send the data to. And then I can configure the different types of landing zones that I want. Do I want to use a Kafka endpoint, a Mini.io, Azure Event Hub, Amazon S3? Really depends on each operation, each functionality. Different companies will have different requirements for security or whitelisting. So in this case, I'm just going to use the Kafka. You can configure it, all the different parameters to make a Kafka connection. And that will just send the data to my tenant ID, to the landing zone, and then to my tenant ID. Then I go to my asset hierarchy. Here I see all the elements that I have in my Pi. So if I go back to my Pi, I see, yes, I have a BLR Corp and I have an industrial sites. So that's exactly what I have here. And then within the BLR Corp, I have my two plants. And then within the two plants, if I go to my shift reactors, I could just go to my heat exchanger. I'm going to click on my shift exchanger, on my heat exchanger, and now I can specify which tags I want to actually send to the Foundry. So in this case, I'm going to use all of them. Sometimes there may be tags with information of manufacturer, model, stuff like that that is constant. There's no reason why you would want to push that to a data platform because it has no real relevance to any analytics that we may run. So in this case, we're just going to specify all of these because they're good. So now I'm going to push it to the landing zone. So I pushed it to the landing zone, and now this entire asset hierarchy was transferred to my IRIS Foundry, and we'll go through that in a moment. But before I continue, I also need to specify my agent to be able to capture the live data. So let me create a new agent. I don't want historical for now. Let's stay with live data. And here you can create as many agents as you want. For now, I'm just going to create a single agent. The reason why you would want multiple agents is because, for example, here, change data. For example, here I have, what is this? Around 10, roughly 10, no, 9. So we have 9 tags that I'm pushing. Maybe some tags are being updated on a different frequency. You want them to be ingested in a different frequency. So therefore, you would want different agents to capture it. Maybe you want even multiple agents for the same tag with different frequencies. Really up to you how you want to visualize the data in the end for your analytics. So in this case, I'm going to put it on 5 seconds. So I'm going to ingest, or I'm going to actually push. So this is a push process where my connector will push the data from my tags, from my Pi, every 5 seconds to my landing zone and then to my IRIS Foundry. So I'm going to push it. Now it's created and it's running. I can stop it, restart it, delete it, modify it, whatever I want to do. Okay, so now we have the data connection. Now let's go back to my IRIS Foundry. Number one, let me show you how this is actually done. So in IRIS Foundry, we have a data transformation pipeline. In the data transformation pipeline, what we are doing is we have an event receiver. So here we are receiving the event from our landing zone telling us, okay, we have new data in the pipeline, handle it, right? We get the payload and push it to the first processor, this asset hierarchy creation. What we do is we just get the payload. We don't get the actual asset hierarchy, right? We get it in a JSON or an XML. Now we need to actually parse that JSON and make sense out of the JSON. What do the different relationships mean? How does that correlate to our system? So here we're going to prepare the request payload. We're going to parse it. We're going to split the JSON into the keys that we need. We're going to create the assets automatically in our Foundry and create the relationships between the different assets and their tags and channels. Once we've done that, we can go to our asset definition. And here let's find our heat exchanger. So I see here my heat exchanger. So in my heat exchanger, I can now specify the manufacturer, the model number, add any custom fields that I want. And I see here all of these channels. So I have 11 channels, right? One is for goodness, for a health score and anomaly that are built in. And then I have channels for the tags that I ingested. SymphonyAI Industrial created this concept of channel to be able to create a unified namespace. Essentially, what we're doing is we create a channel for each measurement, for each sensor that you have on the asset, and then we can associate multiple tags to that single channel. And now if you have, for example, data in a Pi, you have data coming from an OPC UA, you have a data coming from MQTT, whatever it may be, all that data can be correlated to a single channel. And so we have these channels, and what I just mentioned is now we're associating these tags, the tags that we have pushed, right? For example, bed expansion, the outlet temperature, etc. That gets mapped to the heat exchanger outlet temperature. I can change it if it's wrong, but no need. Okay, perfect. Next. And now I can save my asset. So I have the asset, I've created those channels, I've created those tag associations. Then we also have it also pushed in my asset hierarchy. So in my asset hierarchy, I have my BLR Corp, I have my Orion Petrochem plant. And here, if I go to my shift reactors, I now see that I also have a heat exchanger in addition to my shift converters. Perfect, exactly what I wanted to see. And now I can go to my knowledge graph. Select my BLR Corp. And now go to my shift reactors. And now I have a heat exchanger here, which wasn't here before. And I can expand this, see, for example, the volume flow rate, get that information, go and view trends. I can now go to my heat exchanger and compare my outlet temperature, outlet humidity with my flow rate. And I can visualize it different dates. I can add some trend lines to see what's the trend in the data. Of course, this is simulated data. This is not real data. So that's how we were able to bring in the data, bring in the new asset from the OSI PI without needing to touch anything, just create that connector, and it's in my data. Now I can go on and create my analytics, deploy my model, etc., to get some insights from the data that's available in the Pi. Let's go back to the presentation. And I'll hand it over to John to explain a bit more what we were actually seeing here.
Yes, so thank you, Brian. So essentially what Brian demonstrated is from left to right is the historian and then the connector, the Pi connector, wherein Brian created the agent to extract data from specific assets and tags. We've had our customers being a bit concerned about having third-party apps having complete access to an asset hierarchy. And the way we have worked through that problem is by providing the customer the right to select the particular asset, and within that particular asset, a particular set of tags that they would like to extract data from. And that's what Brian demonstrated in as he was configuring the Pi connector interface. From the Pi connector interface, once the agents began to pull in data, live data, Brian then went on and explained how we do that in our transformation pipelines, the various processes in the transformation pipeline to transform data, to contextualize data in a way that IRIS Foundry can consume it. All and final goal being to create an unified namespace, and then the consumption by the downstream applications like copilots, like knowledge graphs, etc. So that was the whole. This pictorial representation was the whole demonstration of the capability of the connector and Iris Foundry to extract data, contextualize, and consume and create a unified namespace. Thank you.
So continuing from that, so you may ask yourself, what's the point? What's the purpose? Or actually, you probably don't ask yourself that because you saw the point as explained. But there's also a financial incentive here, right? As we are ingesting more data from different sources, you're ingesting data from your ERP, you're ingesting data from your CMMS, you're ingesting OEE data from your MOM or MES system, depending on your industry. You're ingesting the asset data for maintenance. You're ingesting the KPIs forecasting of the performance. There's a real tangible financial outcome to this whole experience. And that's where the value lies. So this is an example where we have deployed this connector with a Pi in a glass manufacturer. So before the scenario, there was high variability in the melting process. There was a lot of manual set points of the valves of the gas to air ratio flow pressures to make sure that, or there was no oversight on how much gas is being used to manufacture the glass. There was a very high energy and a lot of emissions during the process to create the glass. So our customer wanted to optimize that. Now, you could try to manually adjust it over time and slowly adjust it, but what we found works is leveraging AI. Now, leveraging AI is very difficult because when you try to tell an operator who's been working in a factory for 50 years, setting those valves, what the optimization should be, they're very reluctant to take the, let's call it quote unquote, guesswork of an AI agent telling them what to do. Therefore, our approach is leveraging that historical data. That's why historian data is so important in addition to the live data, to be able to see what have the operators actually been doing for the past 5 years, 10 years, even 1 year, depending on the operation, the process. What have the operators themselves been doing? See, okay, I had an anomaly in the past that then the operators, with their experience, decided to set this particular setting to the valves. We see from the data, from the analytics, what transpired afterwards, and then we can draw conclusions and analytics. Okay, if I have the same anomaly in the future, I know what procedure to do, how to assign this procedure, who should I assign the procedure to, when to actually maintain it, what setting to set. So performance optimization is key, leveraging the deep learning AI models. So we can already optimize or leverage the historical operators' knowledge how to improve the process, and real-time predictions on what's going to happen should we modify these values, and then show the customer how it's going to change. So in this particular example, we've been able to reduce the energy consumption and generate $1 million of consumption per year in the plant. We've been able to increase 3% of yield in the production and reduce the overall energy consumption by 2% for that particular plant. So there's definitely a tangible value to using this historical data and bringing it into our analytics system so we can easily visualize it in our knowledge graph and run our analytics to be able to draw these insights, find these alerts, assign these to operators. To wrap up, I do want to mention that we are going to have an industrial AI summit in Houston and in Dubai coming up in November. If you want to learn more about our IRIS platform, if you want to have a deep dive into what we showed you today, understand a bit better how these connectors work, what are the other connectors that we have, understand how do we deploy analytics, how do we use our low-code, no-code ML Studio, how can we integrate Jupyter notebooks? How do we leverage our PNID? Anything of that sort. If you have any questions whatsoever, feel free to join us either at Houston or Dubai. We will have a few others coming up in the next few months, but these are the upcoming ones. Feel free to register. November 13th is in Houston and November 19th in Dubai, depending on where you are in the world.